I'm happy to be here. Thank you so much for the invitation to talk about what I consider to be an extremely important topic. I want to start with just one small piece of terminology. AI ethics versus AI safety. Those are certainly related fields, but they're not quite the same, at least not as measured by the center of gravity. AI ethics deals mainly with present-day AI systems and risks arising from these systems being too weak. Whereas AI safety deals mainly with future AI systems. Those will get next year or the year after that, or in 10 years, or so on. And risks arising from them being too strong. An alternative terminology which has often been used, but which I'm trying nowadays to avoid, is to call AI ethics near-term AI, dealing with near-term AI risk, whereas AI safety deals with long-term AI risk. This is a misleading terminology and should be avoided, and the reason that it's misleading is that many of the risks discussed within the AI safety topic can arise actually quite soon. Just for confusion, much of this talk is going to be about the ethics of AI safety. But okay, this is Scott Aronson. He's one of the world's leading quantum computing experts. He's giving this talk in November 2022, just weeks prior to the release of ChatGPT. He is, at this time, he has just started a sabbatical when he's on leave from his university professorship to work for 2 years at OpenAI. At this time, he was relatively a newcomer to AI safety, and he says this. To an outsider hearing the terms AI safety, AI ethics, and AI alignment, they all sound like kind of synonyms, right? And for the moment, I want you to treat AI safety and AI alignment as synonyms. They are not quite synonyms, but they're close. And he says, it turns out, and this is one of the things I had to learn going into this, that AI ethics and AI alignment are two communities that despise each other. It's like the People's Front of Judea versus the Judean People's Front from Monty Python. He's exaggerating the situation somewhat, but there is a tension where one camp accuses the other for stealing all the oxygen in the room, and so on and so forth. I write a little bit about this tension in my chapter on the troubled relation between AI ethics and AI safety in this anthology, which has just recently come out at Wiley, Contemporary Debates in the Ethics of Artificial Intelligence. So I discussed the research landscape in this paper, and at the end of this chapter, I state quite strongly that I think that we should get rid of this perceived conflict, because these fields are not natural enemies, and the fight for attention and resources is not a zero-sum game. There's plenty of oxygen in the room for everyone. The natural enemy to have here is not each other, but the leading AI companies, represented, for instance, by this guy, Sam Altman, CEO of OpenAI. They are behaving recklessly. It's not that they want to create danger in the world. They prefer to avoid that for simple commercial reasons. If they cause small or medium-sized or large catastrophe, it's really, really bad for business. So they're doing some work in trying to avoid that. One manifestation of this is their so-called preparedness framework, which they launched in December 2023, which is just over 2 years ago. And the idea of their preparedness framework is that before they release their new AI models, they test them for potentially dangerous capabilities. And if they are too capable in dangerous areas, they have this self-imposed regulation about what to do. And if they're above a certain level, they can't release them. And in a little bit more detail, we can look at this diagram where we have 4 categories of capabilities, and in each category they measure the capability of the model on a scale ranging from low via medium and high to critical. And based on these levels, they deduce an overall level about the potential for dangerous behaviors in these models. And if this overall score, which is taken as the maximum over the 4 categories, if it's high or more, they're not allowed, according to their self-imposed regulation, to release the model before they have taken safety precautions, bringing down the risk level to the medium level. There are even harder restrictions on what they can do when the level reaches critical. So what are these categories? The first one is cybersecurity. One thing we don't want is AIs roaming around uncontrolledly in cyberspace, walking through firewalls at will and so on, which they might be able to do if they get too good at cyber hacking. So we don't want those capabilities to be too large. Next category is CBRN, which is short for chemical, biological, radiological, and nuclear. And this is, to put it briefly, these are capabilities relating to creating weapons of mass destruction and threats around that. The third category is persuasion, the ability to in various ways deceive and persuade people of stuff. And that is a category which I consider especially important for apocalyptic AI scenarios in a situation as now where we don't yet have good enough robotics for the AIs to use that as their arms and hands in the physical world. And when they're not able to use robots for that, the obvious alternative is to use individual humans to do their biddings in the physical world. And the key to being able to do that is competence in persuasion and social manipulation. So we regard it as dangerous. I do it, they do it in OpenAI. Everyone in this AI safety field thinks that this is really a key category. Then they have the model autonomy, which is sort of the rest of other kinds of potentially dangerous capabilities. And most importantly here is the capacity for AI development, meaning the AI creates the next generation of AI, and this might potentially end up in a dangerous and uncontrolled spiral of self-improvement. So they've been doing this kind of thing for a little more than 2 years now, and things have not been super dramatic because all the evaluations have ended up on level medium or lower. But we seem to be getting to a point according to Sam Altman himself. He tweeted a few weeks ago about their coming soon to be released next generation of AI models, where he says that we are going to reach the cybersecurity high level on our preparedness framework soon. Okay, so that's potentially a dramatic step. And they have these self-imposed rules that they can't do this without handling properly the safety aspect. He mentions some of the things they can do, and in particular, he mentions as their main action here to move to defensive acceleration, helping people patch bugs as the primary mitigation. They're releasing something dangerous, and they're simultaneously releasing some stuff that will help people defend against this. Does anyone remember the movie Mission Impossible 2 and what the main super villain did there? It's a pharmaceutical company releasing a highly pathogenic virus on the world and simultaneously medication against that. I don't see really quite how what OpenAI is planning to do here, according to the CEO, to be all that different from that thing. So why is this happening? There are many reasons for this, but one factor that really plays into this is the speed at which AI is currently improving. And I want to spend this first part of the talk convincing you that this speed is quite high. I want to start in a field that I know reasonably well, mathematics, and I'll ask, can large language models do math? So this is something that changes over time. If we go back to 2019, the foremost model at the time was GPT-2, and the cutting edge of what it was able to do was to solve two-digit addition problems like 9 plus 16. You may think that this is a capability it has not really from any mathematical insight, but simply from having memorized the addition table, which can be found in various parts and forms all over the internet. And I'm not sure exactly how GPT-2 worked in this respect. Maybe this is the case, but if we look at more today's more cutting-edge large language models, they don't work like that. So this image is taken from work by Anthropic. They look at how Claude works internally in dealing with these kinds of problems. And it turns out that the algorithm for calculating 36 plus 59 is something quite different from just going to some internalized lookup table. The analysis proceeds along two lines, one of which does approximate calculations about roughly how big this number is going to be, and another which works out what the least significant digit, the final digit of the sum is going to be. And finally, it merges these two lines of thought and arrives at an answer. A year later, GPT-3 was able to do the corresponding problem, two-digit multiplication problems. So that's a bit more advanced. GPT-4 was this is 3 years later, had improved quite a bit. And in the math part of the American version of the Högskoleprovet we have here in Sweden, they score better than 89% of all the prospective college students. And it solves problems like, I mean, non-standard problems like how many integers between 10 and 500 begin and end with 3. If any of you happens to get bored with this presentation at some point, you can enjoy yourself by thinking about what the answer to this problem might be. 2 years later, GPT-5 is even more capable, and in particular, I think what is most impressive here is that it has assisted, according to top mathematicians and computer scientists like Terence Tao and Scott Aronson, this model has provided key insights for actual mathematical research breakthroughs. And last month, in January 2026, the latest version of GPT-5 solved a problem from an iconic list of open research problem called the Erdős problems. I think this trajectory is quite interesting, and it gets even more interesting if you start to think about where might this be heading 1 or 2 or 5 years down the road. Things are happening. Mathematics is just an example. If you look a little bit broader, but still math related, there's a very interesting data set from an AI evaluations organization called METR, M-E-T-R, and this paper led by Elizabeth Barnes and Lawrence Chan, where they provide, so this is from early last year, maybe March 2025, and they provide what I consider to be the most important diagram that was published in all of 2025. And it's this one, which indicates how AI models improves over the years. And how, so on the x-axis here, this is just time, starts in 2019, continues towards 2025, and then a couple of years into the future. On the y-axis, that's also a kind of time axis, but you may notice it's logarithmic, meaning each step here is a doubling of time. And this measures the depth of the problems that these models are able to solve, as measured by how long it takes for human experts to solve these problems. GPT-2 in 2019 was quite incapable. It could only solve problems that had a depth of a second or 2, like answering some fairly straightforward yes-no question or something like that. And then gradually things got better and better, and now we're hitting the hours here. Now, if you have a straight line on a logarithmic scale, like we have here, so the blue line here is fitted statistically to the observed points, and when you have a straight line like this on the logarithmic scale, this corresponds on the linear scale, the actual times, to an exponential. And when you look at the slope of this straight line, you can actually, from this slope, calculate the doubling time of the exponential. And this slope we see here corresponds to a doubling time of 7 months. So the depth that things can solve today is quite high, but if this trend continues, we can expect it to double in 7 months, and maybe double again if the trend continues a full year or more into the future, and so on. The big question here is, where can this lead? You can observe also, as many commentators have pointed out, that if you look at what's happened just in 2024 and onwards, it looks like the rate has maybe increased a bit. There are various interpretations of this. So if you fit a straight line to that, you get more like a doubling time, like 4 months or 4.5 months or something like that. Nobody knows exactly how to interpret this. Nobody has a crystal ball to look into the future. And it's still possible that these capabilities are about to hit the ceiling, but I don't think that we should bet our lives and our civilization on this. So we're in a situation where many people, possibly including some of you in this room, are not aware that things are moving this fast forward. You see this within the research society, such as, so here's a paper which was published just weeks ago, February 2026, in Nature Medicine, about how medical advice, how good medical advice you get from large language models. And it turns out that it's not so good. The recommendation is you should not use large language models for medical advice. You should ask human physicians. And this hit the news, and there was an interview with the authors in many places, including BBC. And the statements made by the authors here include saying things like, despite all the hype, AI just isn't ready to take on the role of the physicians. And similar claims here and here. And I think that this is just the wrong thing to claim from this study, because if you look in the study and look at what actually the large language models they study are, it's GPT-4o, it's Llama 3, and it's one more model which I actually hadn't heard about, and they are all from the spring of 2024. So what this co-author should have told the reporter is that despite all the hype, AI was, as of summer 2024, still in a situation where they were not as reliable as physicians in giving medical advice. Their study doesn't say really anything about what the situation is now, right now, because it's like if you want to write a paper about the I don't know, the content of the exhausts and pollutions coming out of cars based on the study of Volvo Amazon or something, to take a comparable example. Why did this happen? Well, one reason is that the paper just came out. There is a delay in scientific publication, so that's part of the reason. We could note, however, that they sent this paper to Nature Medicine in May last year, when these models were already 1 year old. So that's not the full explanation. And regardless of the explanation, they shouldn't talk like that to the reporters. It seems that they have no idea that AI keeps getting better and better. And there are other examples of these kinds of phenomena. And when GPT-5 was released in August this year, there was a discourse around that propagated the myth that GPT-5 somehow shows that AI has reached a plateau and the curves are flattening out. Here is one of the headlines, and I even had the opportunity to debate this in Swedish public radio in, was it August or September? But it's not true. So the false impression here was created, I think, mainly by two things. First, a highly bombastic marketing strategy from OpenAI, which set up for people to be disappointed by GPT-5, despite its actually very, very impressive capabilities. The other thing is that people thought they were comparing it to GPT-4, which had been released 2.5 years earlier. But in their minds, they were actually comparing it to the most recent models, and there have been releases much more frequently. And you don't expect, even at the super amazing rate AI is developing now, to have giant leaps every 3 months or so. So let's see where GPT-5 ends up on the meter plot. So here is an updated version, and you see GPT-5 here. Clearly, it's a record level, and it's clearly above the 7-month doubling trend line. If you're not used to logarithmic plot like this, I'll give you the linear plot. It looks like this, and here we see even more clearly that the GPT-5 does not represent a slowdown in AI capabilities. So that was in August, and things have continued since then. So last time I downloaded this diagram, we had data from Claude Opus 4.5 and GPT 5.2, and you see that compared to them, GPT-5 is quite far behind. So things are really continuing upwards. Where will this lead? Nobody knows. And as I said, there's no law of nature that says that these trends must continue, but they might. Former OpenAI researcher Leopold Aschenbrenner had a paper in 2024, which was, I think, really the first one that went public with a discourse that had been around in San Francisco and Silicon Valley and that AI ecosystem around there for some time about where things were heading. And it's a 100-page report, so it contains a lot of detail, but some of his conclusions are boiled down in this diagram. Again, we have time going from left to right here. In 2019, he judged that GPT-2 was, as regards to general cognitive capabilities, on the level of a preschooler, something like that. GPT-3 more like an elementary schooler, GPT-4 more like a smart high schooler. Where is this pointing towards? He suggests, and of course this is not rigorous as I show it, and it's not even rigorous in his report, but it's supported by arguments, that somewhere around 2027 we should have to expect AIs on the level of whose AI research capabilities are on the level of some of the best AI researchers that companies that like OpenAI and Anthropic can access at present. And that is kind of it's an interesting benchmark, because at that time, when AI replaces humans as the best AI developers on the planet, we may see things accelerating due to a kind of feedback mechanism with recursive self-improvement. And this is an idea that goes far back. This is a 1985 paper by mathematician Ray Solomonoff, who uses, he models computer progress in terms of differential equations, and he shows that the differential equation changes quite drastically when the thinking going into the progress comes from the AI itself rather than externally. So when it's external, it's something like this, which gives an exponential, and when it comes internally, you get an extra factor y in the right-hand side of the differential equation, and that leads to curves that are much more dramatic than exponentials. They hit infinity in finite time. Nobody believes in hitting infinity in finite time. That's unphysical. That's not going to happen. But these kinds of arguments suggest that we may be in for something quite dramatic in terms of AI development acceleration. And people have looked at this in more recent years and more empirically and look at what seems to be happen based on earlier data. And here is a parametric model by two guys, Eth and Davidson, where the r equals 1 case, which is a kind of borderline case, is the one that Solomonov looked at. And if you have r bigger than 1, then you have this explosive behavior, and r less than 1 is more like a slowdown behavior. And they looked at various areas of software development and estimate r, and they get different values. In computer chess, for some reason, they get the smallest r, 0.8, but the other r's are above 1, suggesting that maybe we'll get a software-driven intelligence explosion of some kind. And these are the sorts of reasons lying behind Aschenbrenner's reasoning, and he thinks that somewhere around 2027 we'll see market acceleration on something, on a scale which is already logarithmic, towards what we in AI safety jargon is called superintelligence levels, AIs that are smarter than humans, much smarter than humans across the board of cognitive capabilities. What happens then? Nobody knows, but one can speculate. An early speculator is Alan Turing. More than 30 years ago, I read this biography by Andrew Hodges, a fantastic book. I reread it last month, and it was really, really worth rereading, and it became clear to me how Alan Turing's interest in thinking about the future of artificial intelligence is not just something he did the last couple of years of his life, but it was visible throughout much of his research career. But here is one such late, I mean, most of what we know from him is quite technical and mathematical work, but some is quite philosophical. And here is his 1951 paper, a short quote. "My contention is that machines can be constructed which will simulate the behavior of the human mind very closely. Let us now assume, for the sake of argument, that these machines are a genuine possibility and look at the consequences of constructing them. It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. There would be no question of the machines dying, and they would be able to converse with each other to sharpen their wits." So here he suggests already this kind of self-improvement behavior that I talked about. At some stage, therefore, we should have to expect the machines to take control. Okay, what happens when the machines take control? Well, we don't know the answer to that either, but surely it depends on what the machines are inclined to do in that situation. What are their drives and values and desires? If they are in line with ours, things can go pretty good. But if they are not, maybe not. So this points to the importance of making sure that their values are ours. This is what we nowadays call AI alignment, this term that I refused to define in the beginning. But this AI alignment is the subfield of AI safety work, which deals with making sure that the first really capable AI systems have values, the values that we want them to have. So one would think that the AI community, which got started, in fact, only after Turing had died tragically in 1954, that they would somehow take these words to heart and think about them and so on. But really, for the next 50 years, nobody in the AI community cared. Nobody in academia at all. I mean, Hollywood took it seriously, but academia did not, with very, very few exceptions. One brilliant exception is Norbert Wiener in this 1960 paper, where he discusses the hypothetical situation that we build a machine so powerful that we don't know how to stop it. And he says that in such a situation, we had better be quite sure that the purpose put into the machine is the purpose which we really desire, and not merely a colorful imitation of that. So that could be taken actually as a pretty good summary of the vision of AI alignment research as it looks today. Okay, then there were several more decades where nothing happened. only in the after the turn of the millennium, in large part thanks to this AI safety pioneer S.E. Yudkowsky, things started to happen to some extent at least. Yudkowsky has a highly influential 2008 paper, and I say this not only because it influenced me profoundly, but I have many colleagues who experienced the same thing. He has this 2008 paper from which I'm going to give you one sentence, a very short quote, which gives what he thinks is the default scenario if we get super intelligent AI without having solved the alignment problem. He says this: the AI does not hate you, nor does it love you, but you are made out of atoms which it can be used for something else. This is not the kind of conflict we want to end up in with a superior opponent in terms of intelligence and capabilities. Maybe you remember, just to fast forward to 2024, Geoffrey Hinton's talk at the Nobel banquet after having received the physics prize. An existential threat will arise when we create digital beings that are more intelligent than ourselves. We have no idea whether we can stay in control, but now we have evidence that if they are created by companies motivated by short-term profits, our safety will not be top priority. We urgently need research on how to prevent these new beings from wanting to take control. They are no longer science fiction. I mean, this is one of the most qualified AI researchers in the world, and Joshua Bengio, who is the most cited of all AI researchers in the world. He says similar things, and there are others. Okay, sounds like we're in a dangerous situation. I often hear counter arguments when I talk about these kinds of existential AI risks. And the three main categories of counter arguments are AGI denial, rose-colored glasses, and AI successionism. Let me say a few words about each of these. AGI denial, that's the claim that these machines, they are just stochastic parrots, to quote a very popular term, or glorified autocomplete. They have no real intelligence. So there's really nothing to worry about. We're not on a trajectory towards anything exhibiting real intelligence. My favorite response to this kind of argument is to compare to humans. So here, I'll give you one example here. So when GPT-2 had come out in 2019, one anonymous AI researcher said, I still think GPT-2 is a brute force statistical pattern matcher which blends up the internet and gives you back a slightly unappetizing slurry of it when asked. So this guy was not impressed. Scott Alexander, my favorite AI blogger, he responded that, yeah, well, your mom is a brute force statistical pattern matcher blending up the internet, and so on. And I have yet to see an argument for why large language models lack intelligence, which cannot be easily modified into a similar argument for why humans don't have intelligence either. And when we have done that maneuver, we see that the original argument, there's either something wrong with it or defines intelligence in a way which has such a high threshold that it becomes really irrelevant to the discussion of whether we will get superhuman AIs or not. And I have this, since November last year, I have this Substack called Crunch Time for Humanity, where I write about AI risk and AI safety. And if you want to see something like a summary of what these kinds of arguments are about, you can read my Yo Mama Substack post from December. So that's AGI denial. The rose-colored glasses view is the view that, okay, AGI can happen. Maybe I didn't even tell you what AGI is short for. Artificial General Intelligence. That's something that matches or exceeds human intelligence across the entire range of relevant cognitive capabilities. Maybe we can get such a thing, but why in the world would AI want to hurt us? That's the counter argument. And I mean, responding to that is a little bit complicated. There's a big literature on this. It requires a careful discussion about the theory of ultimate versus instrumental AI goals, so-called orthogonality and instrumental convergence. Instrumental convergence is you can expect any sufficiently intelligent AI to pick up certain sub-goals to promote their ultimate goal, no matter what this ultimate goal is. Things like self-preservation will help the AI reach its ultimate goal. Resource acquisition, similarly, and there's a bunch of other things. These instrumentally convergent goals tend to be quite dangerous. The theory behind this is outlined in books such as Nick Bostrom's Superintelligence, a classic, 2014. Very, very old book, actually, by AI standards. Almost 12 years. My own book, Tänkande Maskiner, for those of you who read Swedish, or the one I recommend now most of all, is L.C.A. Yudkowsky's and Nate Soares, If Anyone Builds It, Everyone Dies, Why Superhuman AI Would Kill Us All. So this is mostly theory, but these kinds of conclusions are increasingly backed up by experimental evidence, where they do things like they let the AI in an experimental situation get access to documentation that leads us to think that it will be replaced if it becomes dangerously capable at arithmetic. And then they test the arithmetic capabilities of this AI, and it performs worse compared to if they hadn't received this prior information that it could be dangerous for the self-preservation of the model itself to be good at arithmetic. This kind of situational awareness and strategic thinking is beginning to emerge quite rapidly in these machines. The final category I want to mention here is the AI successionists, those thinkers like, for instance, Google co-founder Larry Page and well-known Silicon Valley billionaire Peter Thiel, who think that AI replacing humanity is just fine, just the next step of evolution or whatever. And I talk about AI successionism at some length in another post of my Substack. For those of you interested in that. So evidence is accumulating that existential risk from AI is a real thing. And we know that the leaders of the leading AI companies are aware of this. In 2023, when this issue had a kind of a public breakthrough, we heard Sam Altman repeatedly get the question in interviews about what's the worst case scenario in case you fail with AI safety, and he talks openly about lights out for all of us. And his colleague Dario Amodei, who is CEO of Anthropic, he even quantified the risk that this would happen to somewhere between 10 and 25%. It's a very, very rough and subjective estimate, but this is what he thought. Both of them, along with them is Hassabis, who is head of Google DeepMind. They were all signatories of this open letter from May 2023 calling for mitigating the risk of extinction from AI, and that it should be a global priority alongside other societal scale risks like pandemics and nuclear war. So they know about this. And on top of this AI evaluations procedure that I talked about in the beginning, where they are hitting level high in cybersecurity, it seems to be in a crisis as we move on from the current dress rehearsal towards the real deal, which can be actually quite close. So there are several reasons why AI evals are about to stop functioning. So here are some of the main shortcomings. One is that AI evals, you test how the AIs react to various kinds of environments and promptings and so on, and it can only provide a very sparse sample of the huge space of possible interactions and promptings that you can have. So there's no way really it can provide full assurance. We knew that all along, but on top of this, when AIs start to become capable of deceiving us, which is something these situational awareness experiments point strongly towards. Then AI evals break down because the AI can pretend not to have the capabilities that they have. Furthermore, carrying out AI evals requires the safety team to have access to these machines. So they have to be internally deployed, but that is potentially catastrophically dangerous as well, unless we have made sure that they don't have these dangerous capabilities. So we need to know that before they are tested, which is kind of a catch-22 situation. This really is a crisis of this whole testing paradigm. And I think that until these companies can come up with a better paradigm, they can no longer, in my view, ethically release their models. This seems unfair because there is no such paradigm in the pipeline, but fair, unfair, I don't know. Here is Stuart Russell in an AI safety meeting in Paris I attended a year ago, saying something that I think, not everyone thinks this is obvious, but I think this really is obvious. It is entirely reasonable for governments to impose safety requirements that manufacturers cannot meet. If you have the safety requirement that you should have to establish before releasing an AI model beyond reasonable doubt that it will not create global catastrophe, that's a very reasonable requirement. But they say, no, there's no way we can meet it because AI evals doesn't work that way. Okay, then you cannot release any more models of this kind. Okay, the title of my talk contains the phrase, the ethics of risking everything. What is the ethics in the situation where they keep releasing these potentially dangerous models? Why do they keep racing ahead despite awareness of the risks? There are some candidate psychologies going on here. Do they think that if not us, then someone else? Does this generally legitimize any action they may take? They certainly, I could show many examples where they think in these terms. Representatives and Anthropic saying, we have to do this because they're doing the same thing at OpenAI or at Google DeepMind. Are they under the spell of we can handle it macho culture? Maybe. Do they consider it important that humanity's survival and future flourishing, important to the humanity's survival and the future flourishing, that they beat their competitors to the great breakthrough? They say this. At Anthropic, they say it's super important that they come first because they have the best AI safety. They say the same thing at OpenAI. At least one of them must be wrong here. So I think they should get a grip on themselves. Are they under the influence of perverse company and market incentives? Certainly yes. I think all these mechanisms are at force here, and I think none of them provide any ethically acceptable reasons for acting the way they do. I strongly recommend the very recent essay by Anthropic CEO Dario Amodei called The Adolescence of Technology. It's a follow-up of a similar essay he wrote in the fall of 2024 called Machines of Loving Grace, where he outlined the situation he was hoping for if they were able to successfully create super powerful AIs for the better of mankind. In this new essay, he talks about the risks. And it's good that he talks about the risks and he talks about it so openly. And the report, the paper has a lot of good insights. But there are also plenty of revealing passages. And when we come to the very end of the essay, he says this: the years in front of us will be impossibly hard, asking more of us than we think we can. But in my time as a researcher, leader and citizen, I have seen enough courage and nobility to believe that we can win. That when put in the darkest circumstances, humanity has a way of gathering, seemingly at the last minute, the strength and wisdom needed to prevail. We have no time to lose. This is very pompous language, and it seems to me that he has this self-image of this hero that will save humanity in this very, very dangerous situation, where he could instead just stop building these models. But he says, I mean, he mentioned in a panel discussion with Demis Hassabis in Davos just last month. They were united in the view that if it could be organized, that if all of these leading AI companies would pause development in order for AI alignment research to catch up a little bit, that would be a good thing. But they were also very united in the judgment that this is not possible, and he says it again in this report. And I think that that kind of pessimism is super dangerous. Here is Nick Bostrom again. He has a new, I mean, he used to be sort of a hero of mine, because what he did with the book Superintelligence in 2014 and other things, I mean, he has done more than just about anyone else to raise awareness about AI safety. But his latest paper, which came I think last week, he has had a change of heart where he says that we should go full speed ahead. Why does he think so? It's quite an interesting explanation. It's not that he denies AI risk now. He thinks it's as present as ever before. And it's not that he thinks that, okay, if humanity is wiped out, that's the next step in evolution and everything is fine. Instead, he says this: developing superintelligence is not like playing Russian roulette. That's a kind of rhetoric that I've been using in newspapers and so on. Not like playing Russian roulette. It's more like undergoing risky surgery for a condition that would otherwise prove fatal. 170,000 people die every day of disease, aging, and other tragedies. And the only way that we can reasonably stop death, at least in the short time perspective, is if we build superintelligence. And then he says, this is worth the risk. And he has calculations showing that under some circumstances, even a 95% probability of an AI apocalypse would be worth it to save him and the rest of us, for at least getting a chance of radical life extension. Here are Nick Bostrom and Dario Amodei in an image that GPT-5 helped me make. And yeah, there are other crazy people too, like J.D. Vance, also from Paris last year. He said this: it's very anti-safety. He says, I'm not here this morning to talk about AI safety. The AI future will not be won by hand-wringing about safety. It will be won by building. And a little later in the same talk, he says that the AI economy will transform the world of atoms. And if you remember the Yudkowsky quote about atoms I gave, I think this is quite frightening. And with that, I thank you for your attention.